Today we're going to continue our discussion on solving quadratic equations, but we're going to use a process today of solving quadratics by the use of factoring. So factoring is anytime we take a number or expression, we're trying to break it down into two either numbers or expressions again that would be multiplied together to give you the original number or expression. So take, for example, the number 24. So if I want to factor 24, what I'm going to do is think about two numbers that I would multiply together to give me 24. So a couple examples, I would have 1 and 24. I could have 2 and 12. I could have 3 and 8. I could have 4 and 6. And that would be it. So these are all considered factors because they are two numbers that multiply together to give me the number 24. So we can do this idea with numbers. We can also do this with expressions. This is what we're going to be doing today. So let's say that I had an expression of, let's say, 2x squared plus 4x. So when I think of factoring an expression, what I'm going to do is try and figure out what do these two terms within this expression have in common. Well, I see that I have a 2 and a 4, so I know they're both even numbers. So I know that they have a 2 in common. And then they both have an x, right? This one has an x squared and an x. The thing about x squared means that there's an x times an x, whatever that would be. So both these terms, have an x in common. So if I were to think about it, I can take 2x and multiply it, let's say, by x plus 2, and those would be considered two factors, because if I were to backtrack and multiply these things by distributing, what I would get is 2x squared and 4x. So what I'm doing when factoring something is I'm taking whatever the original number or expression is, and I'm going to try and break it down into two things that would multiply together to give you that. Now, what we're going to be looking at today is we're going to focus more so on expressions instead of just numbers. But the way I want you to think about this is by using a process of factoring that you guys probably learned about before called the greatest common factor. The greatest common factor is when we look at two numbers or potentially two expressions, is we're going to try and figure out what is the largest multiple that they have in common. So think of 24. I already did the list for 24, so we know it's 1 times 24, 2 times 12, 3 times 8, 4 times 6. And for 40, I would have 1 times 40, 2 times 20, 4 times 10, and 5 times 8. So I have here two lists of factors, factors of 24 and factors of 40. So when I talk about the common factor, is what do these two numbers have in common in terms of their factors? So starting with 24, I see the number 1 here and the number 1 here. I see the number 2 in both lists. And then I also see the number 4 in both lists. And looking at it, I see the number 8 in both lists. And that's about it. So I have some common factors of 1, 2, 4, and 8. Now, what is the greatest of these common factors? The greatest common factor in this case would be the number 8, because both numbers have 8 in common, and it's the largest of the two. Now, this is, again, greatest common factor we can find between two numbers. What we're going to look at is trying to find the greatest common factor between two expressions. So let's take this first example here. So I have two expressions here, 2x squared plus 8x. Again, this is going to be a quadratic equation, and I have the same thing here, 6x squared minus 15x equals 0, another quadratic equation, but this is what's meant by an expression. Instead of just a number, I have two terms here, 2x squared and 8x. Here's what I'm going to try and do is I'm going to try and take each term, and I'm going to try and figure out what do these things have in common. To do that, I'm going to find factors. To find factors of a term that contains both numbers and variables, I'm going to look at first the numbers. I have the number 2. Now, the number 2 is what's called a prime number. It only has a factor of 1 in itself. And then notice that I have x squared. So what I'm going to do when I think about x squared is I want to think about, okay, what does it mean to have x to the second power? X squared literally means x times x. So those two x's multiplied together are technically factors of x squared. I can look at the same thing for 8. I would have 1 and 8. 2 and 4, and this one just has an x, so think of this as 1 times x. Okay, it's not going to be x times x, but it's going to be the number 1 times x. So when I look at these two lists, what do they have in common? Well, I notice that they both have a 2 in common, and also notice that there's an x in each list. So the thing that they have in common is 2x. That would be considered what's called the greatest common factor. But all factors come in pairs, meaning what is 2 multiplied by to give me the expression of 2x squared and 8x. The way to view this is to think about if all factors come in pairs. If you look back, what are these numbers paired with? Well, you can see that the number 2 is paired with 1, the x is paired with another x, this 2 is paired with a 4, and that x is paired with a 1. So what I'm going to do to figure out what's left behind is I'm going to multiply the things that are left behind together. So for example, 1x came from the first term, and then plus 1 times 4 would be 4. And because these two things are left behind each term, I'm just going to separate them by parentheses. So in the end, I would have 2x times 1x plus 4. The 2x is the greatest common factor, and the 1x plus 4 is what's left behind. So what I've now done is I've taken this expression of 2x squared plus 8x, and I've now factored it. Then we're going to look at what happens then when I have it equal to 0. Same thing here. Okay, I have 6x squared minus 15x. So I'm going to look at the 6x squared, the 15x. I'm going to think of factors. So for 6, I have 1 and 6 and 2 and 3. And the x squared, again, means it's x times x. For 15, I'd have 1 and 15, 3 and 5, and then it's 1 times x. And notice that I have the negative here. I'm not going to worry about the negative right now. What do they have in common? Well, I see they have a 1 and a 3 in common. So based on those two, I know that 3 is the greatest. And then also in terms of x's, they both have an x in common. So the greatest common factor here would be 3x. So what we're going to do is we're going to take that common factor and we're going to multiply it by whatever would be left behind. So the 3 is paired with the 2. The x is paired with the x in the first term. So I would have 2x left behind in my first term of the expression. And then the 3 is paired with a 5, and the x is paired with a 1. So that means 1 times 5 would give me just 5 at the end. So I'd have 5 left over in my second term. And then because here, notice there's a minus sign in between, I'm going to keep that negative with the 5, or that minus. And then again, for the equation would equal 0. But the idea here is what we're doing is we're taking these expressions and we're factoring them out. So factoring is to split them out. And by doing this, we're finding what's called the greatest common factor. All right, let's try 2 examples on your own. So I have 3x squared minus 9x, negative 2x squared plus 6x equals 0. So I want you to find the greatest common factor and then think about what's left behind to find our 2 factors for this expression. All right, so my first one, I would have 3x is the greatest common factor. And it's common in both lists. And then what's left behind is 1x and then minus 3, paying attention to my signs. Second one, I have 2x would be common in both of these. And then what's left behind would be the 1x and the 3. Now, because that's a negative, it's negative 1x, and that's a positive, so it would be plus 3. So again, what we're doing here is this is factoring an expression by finding what's called the greatest common factor. All right, in those previous examples, what we had was just simply 2 terms. So we had, for example, 2x squared and let's say 8x, and we factored those 2 terms. So what we're going to talk about next is how we factor something that has 3 terms. So it is possible to look at something that has 3 terms, what's called a trinomial, okay? Tri just simply means the number 3. So for example, a quadratic equation written in standard form is technically a trinomial. But if I look at these 3 terms, let's say x squared, 6x, and 8, these 3 terms do not have anything in common. So if I did x squared, that's simply x times x. If I did 6x, that's 1 and 6, 2 and 3, and then it would be 1 times x, and then my 8 would be 1 times 8, 2 times 4. Now I might say, okay, they have a 2 in common, but there is no 2 found in here. So if I look at all 3 lists, there might be something in common in 2 of the terms, but there's nothing in common in all 3 of the terms. So this cannot be factored by finding something that they have in common. So instead, we got to factor it a different way. So anytime we get a trinomial that we're going to try and factor, we're going to factor this into 2 expressions that again would be multiplied together, but our expressions are going to look a little bit different. anytime we factor a trinomial, we're essentially going to break it down into two what's called binomials. These are actually linear functions. So x plus 2 and x plus 4. So again, factoring is kind of like undoing multiplication. So to show you this, if I were to multiply these two things, so x plus 2 and x plus 4, normally when we multiply things like this, we would want to distribute. But what I have in front is instead of one term, I have two terms. I have the x and the plus 2. So I'm going to start off first by distributing my x. So I would have x times x, which would give me x squared, x times 4, which would give me 4x. Then I would distribute the 2. I'll show that below. So 2 times x would give me 2x, and 2 times 4 would give me 8. Now I multiply those things together and notice that in the middle I have two terms, 4x and 2x. Those are both like terms. So to simplify this, one last step, if I do 4 plus 2, I would get 6x. And then at the end I would have my plus 8. Again, these three things are not like terms because the x squared, even though it has an x, the exponent makes it different than the 6x. And the 6x, even though it has a number, can't be combined with 8 because this has an x and that doesn't. So these three things are not like terms, so I can't add them together. But what I formed by multiplying these two binomials together is what's called a trinomial, or notice a quadratic function, x squared, 6x, and 8, which matches our ax squared plus bx plus c. Now what we're going to do today is instead of multiplying these things together to get my end result, so I'm not going to start here and end here, but we're going to work backwards. So if let's say I give you my original function of x squared plus 6x plus 8, what we're going to do is we're going to split this up. We're going to think about, okay, I'm going to multiply two things together. In order to get x squared, that means I need an x here and an x here. And then I'm going to have two numbers like 2 and 4. Those two numbers have to add together to give me the middle. 4 plus 2 gives me 6. And they have to multiply together 2 times 4 to give me 8. So if I think of, okay, what are two numbers here that would multiply together to give me 8, and those same two numbers would add together to give me 6, the only things that would work here would be 2 and 4. So the 2 and the 4 would go in these two spots. So this process right here of taking something and breaking it into two pieces that are multiplied together is a process called factoring. Okay, so our goal is to factor these trinomials. So to do this, again, we're going to split up our pieces. So I'm going to start off first by placing my parentheses, because again, it's going to look like this. It's going to have x plus some number, call it a, times x plus another number, call that one b. So to split this up, x squared, again, we would get by multiplying an x times an x. So I'll put an x in the beginning or the first spot of each binomial. What I then have to think about are the numbers. So if you think back to the other example that I had, the two numbers that I would place in these remaining spots, those two numbers have to first multiply to the last number 16, okay? And then those same two numbers have to add to the middle term of 10. So if I think of numbers that multiply to 16, I would have 1 and 16, 2 and 8, 4 and 4. Those are factors of 16. What I got to do is think of which combination would add the 10, and hopefully you can see that it's 2 and 8. 2 times 8 would give me 16. 2 plus 8 would give me 10. So that means my factors are going to be x plus 2 times x plus 8. So what I've now done is I've taken that trinomial and now factored it into two binomials. Same thing here. I have x squared plus 7x plus 6. So I would place x here. I'm going to think of two numbers that would multiply together to give me the last term of 6. And those same two numbers have to add to 7. And hopefully you can recognize that it would be, in this case, 1 and 6. So I'd have plus 1 and plus 6. Okay? Now in terms of where I place the 1 and 6, common question I get is, does it matter if I place the 1 here, 6 here, or flip them 6 and 1 there? In this case, it does not. Okay, it does not matter where I place those two things, because when I multiply them, 6 times 1 or 1 times 6 would give me the same result. All right, next example, we're going to do the same thing, and you'll just see here that I have, again, my x squared minus 8x plus 12. The only thing that's different here is the minus 8. So what I'm going to think about is the same process. What two numbers multiply together give me 12, and those same two numbers now have to add together to give me the middle term, which is now negative 8. So the process here is the same. We have, again, 12. So factors of 12 would be 1 and 12, 2 and 6, and 3 and 4. So which combination would give me the number 8? And you can see here that it would be 2 and 6. But I don't want just 8, I want negative 8. So what I got to think about is what would I do to these two numbers in order to get negative 8? Recognize that they would have to both be negative numbers, so negative 2 and negative 6. That means my factors would be x minus 2 and x minus 6. And again, since both of those are negative, it doesn't necessarily matter where I place them in the parentheses. The idea is that's going to be negative 2 and negative 6. The other interesting part I kind of skipped over is that when I multiply two negatives together, that's always going to give me a positive. So the pattern of negative 2 and negative 6 would match here. So I'm going to do the same thing here with x squared minus 4x plus 3. Set up my parentheses, splitting apart the x squared, I get x and x. And again, I want two numbers that would multiply together to give me 3. And those same two numbers would add together to give me negative 4. And hopefully you'll see here that, okay, 1 and 3 would add up to 4. So in order to get negative 4, they would both need to be negative. So I'm going to do x minus 1 and x minus 3. And I've now factored that trinomial. All right, last set of examples with the trinomials. Now notice that I have the first term is positive, second term is positive, and the third term is negative. Set this up the same way. I'm going to split this up by splitting up the x squared into x times x. And now I want two numbers that would multiply to negative 21, and those two numbers would have to add to positive 4. Now I'm going to think about this in reverse. If I have two numbers that multiply to a negative number, that must mean that one of these boxes has to be a negative, okay? So if I think of factors of 21, I have 1 and 21 and 3 and 7. Hopefully you can see that, okay, the combination of 3 and 7 could get me to negative 21, and it can get me to 4. So how do I take 3 and 7 and get positive 4 out of that? What I would have to do is take 7 minus 3. That tells me that the 3 is going to be negative and the 7 is going to be positive. So my two factors would be minus 3 and positive 7. So in the parentheses, I'm going to do x minus 3, x plus 7, and I've now factored that. In this case, the only thing that matters is to make sure that the negative sign, in this case the minus, is attached to the right number. But again, I could put plus 7 here and minus 7 here. So when I have this minus at the end, I just got to think about this one a little bit differently because one of the numbers has to be negative. All right, the last one here, I have my two binomials. I'm going to split up x squared to get x and x. I'm then thinking about what two numbers would multiply to negative 15. What two numbers would then, those same two numbers would have to add to positive 2. Because of the negative 15, one of those numbers has to be negative. So in this case, you can think, okay, 3 times 5 would give me 15 and would also combine to give me 2. So in order for that to be positive 2, I would need negative 3 and positive 5. So my two factors would be x minus 3 and x plus 5. And there we go. We've now factored trinomials. All right, now putting this all together, our main goal when we talk about factoring is we're going to try and solve the equation. This whole mess that we've been talking about now is all with the end result of solving things. So all the equations you're going to be given, all these quadratic equations are going to be set equal to 0. And our goal is to factor these things. So when we factor things, we are trying to figure out what two things would multiply together to give me that number or that expression. So in the end, we are getting two terms that are multiplied together. And like we said when we talked about solving using square roots, we're trying to set our equations equal to 0. So this brings about something called the zero product property. It's actually a special case that we can apply anytime we try and factor something. And what the zero product property says is this, is that if I'm multiplying two things together, whatever those two things are, and I get 0 as an end result, that means one of these two things must be 0. Meaning, it could be 0 times 2. That would give me 0. It could be x times 0. That would give me 0. It could be 0 times x minus 4. That would give me 0. Anytime I multiply something by 0, I always get 0. All right? So what we're going to use is we're going to use the zero product property to help us to solve. It's going to take a little bit of thinking, though. So let's take, for example, we look back at our first problem where we factored out a greatest common factor. Let's say I get two terms, 2x and x minus 4 equals 0. So what I'm doing is I'm multiplying 2x times x minus 4, and I get 0. Now, if I'm multiplying two things together, so I'm multiplying here the 2x and the x minus 4, those are my two pieces, and I get 0, what I have to understand is that when I multiply two things and I get 0, that one of these two terms could be 0. That's how I'm going to solve this. I need to figure out first, okay, if I have 2x, 2 times what number would give me 0? And this one's pretty easy. X would need to be 0. Okay? Now when x is 0, again, if I look at this, 2 times 0 would give me 0. But 0 minus 4 in the second part, that'd give me negative 4. So it's like saying, okay, 0 times negative 4, which would give me 0. So when x is 0, it makes the first term 0. But the second term, if I think x minus 4 equals 0, okay, what would make this term 0? Well, in this case, if I add 4 to both sides, I would get x equals 4. Okay? Now, 2 times 4 gives me 8, but when I look at the second part, 4 minus 4, it gives me 0, and 8 times 0 also gives me 0. So in both these cases, 0 and 4 would end up making this equal to 0, which is what I'm trying to figure out. So what I'm going to do is I'm going to take each of my factors and set them equal to 0 and essentially solve. So let's say we're factoring a trinomial and we get something like this, where I get x minus 3, x minus 9. What I'm going to do is I'm going to take my first piece, x minus 3, I'm going to think, okay, what value of x here would give me 0? In this case, I'd get x equals 3. And here, what value of x would give me 0 if I have x minus 9? In this case, x would have to equal 9. Again, 3, when plugged in, 3 minus 3 is 0. 3 minus 9 would be negative 6. So it makes the first term 0. Here, 9. 9 minus 3 is 6, but 9 minus 9 is 0. So again, when I multiply something by a 0, I'm going to get 0. All right, so now we're going to put this all together. We're going to talk about solving by factoring. So here are some examples of solving using greatest common factor. So greatest common factor, I have 2x squared. I have 10x. So if I break this apart, I have 1 and 2, x times x. For 10, I would have 1 and 10, 2 and 5, and then 1 times x. So factoring this out, I know that they have a 2 and an x in common. So I would write this as 2x times, and what's left behind would be 1x minus 5, and that's going to equal 0. Now what I'm going to do is apply the zero product property. If this equals 0 and I'm multiplying two things, then I'm going to say, okay, what value of x would make the first part 0? In this case, x would need to equal 0. What value of x would make the second factor equal to 0? So in this case, I get 1x equals 5, which just means that x equals 5. So now I'm factoring, and then I'm using the zero product property to actually figure out what my value of x's would be. Same thing here. I have negative 3x squared plus 15x equals 0. Why don't you guys try this one on your own? See what you would get here when factoring and then solving. All right, then the greatest common factor here would be 3x, and then times the remaining, which would be negative 1x plus 5, and that's equal to 0. And then using the zero product property, I'm going to take, okay, what value of x would make this 0? So that would be obviously 0. And then what value of x would make what's in the parentheses equal to 0? So there we'd have to subtract 5. Made a little boo-boo here, folks. Subtract 5, then divide by negative 1 would give me actually positive 5 and not negative 5. Slight little boo-boo there, folks. Okay, but again, I factored out the greatest common factor, then solve. Last example here, now we're going to factor the trinomial and solve it. So to do this, I'm going to split up again my x's, so I have x squared. I'm now thinking about, in this case, what two numbers would multiply in this case to a negative 10, and those same two numbers have to add to a negative 3. So what I can think about here is 5 times 2. Oops, that's 5 times 5. 5 times 2. In order to get a negative 3, it'd have to be a negative 5 here. So it'd be negative 5 plus 2 and negative 5 times 2. So in the parentheses, I'd have x minus 5 and then x plus 2. Now the equation's equal to 0. So down here, I'm going to take each part, x minus 5, and think about what value of x here would give me 0, which would be 5. And then lastly, if I have x plus 2 equals 0, what value of x here would give me 0? In this case would be negative 2. Boom. I've now solved it by factoring and then using the zero product property. All right, I want you guys to try this last example then on your own. X squared minus 8x minus 9 equals 0. All right, in this case, we have x minus 9 times x plus 1 by factoring, and then by using the zero product property, I would get x equals 9, and x equals -1. A lot of meat and potatoes in this video lesson, folks, on factoring, both by using the greatest common factor and factoring a trinomial, and then the idea of using the zero product property to solve when you have two factors equal to 0. So make sure you jot down any questions you have, and we'll see you guys in class. Bye now.